Alright, this problem says if a pendulum driven clock gains 5 seconds per day, what fractional change in pendulum length must be made for it to keep perfect time? So the period of a pendulum is given by 2 pi square root of L divided by G. Now, if you take the dt, the change in the period is with change in length is given by 2 pi square root of G. We're going to do d square root of L. So what this formula is saying is what would be the change in the period of the pendulum if the length changes by this amount. So, okay, if square root of length changes by this amount. Okay, so dt is equal to 2 pi square root of G, and d of that is d of L to the power half is 2 pi square root of G 1 half L to the power of minus 1 half dl. Okay. So dt is equal to 2 pi square root of G 1 half square root of L dl. Okay, so we will divide this by the period, and that's equal to 2 pi root of G 1 half dl square root of L divided by 2 pi L by G. And now let's cancel all terms there. This cancels with that, and the square root of L comes down here, and that becomes an L. So what we have is dt by t equal to 1 half dl by L. Okay, so what this is saying is, let's say you had a pendulum of length L, you increased its length by dl. The increase in, so when this is positive, that would be positive. The increase in period divided by the whole period is given by half times the fractional increase in the length. Okay, so if your pendulum gains 5 seconds a day, so this would be 5 sec. This ratio would be that number. Again, that would be the fractional increase in time, and that's related to the increase in length. Okay, so if you want to decrease it by 5 seconds a day, then you would have to decrease the length by this factor. Okay. All right, so let's add a page below. Okay, so dl by L equal to 2 times dt by t. Okay, so since you want to decrease it by the 5 seconds a day, you have to decrease the length of the pendulum. Here's the fractional change you have to do. 2 times 5 seconds, and in one day you have 24 hours, and each hour has 3,600 seconds. Okay. So that's the kind of change you would have to make. One 1.16 into 10 minus 4. Okay. So in percentage, dl by L would be 1.16 into 10 minus 2%. 1.16%. You have to decrease the length of the pendulum by 0.0116%. So that's how accurately the length has to be designed for a pendulum clock. Okay, so that finishes